Well, the whole reason I started this project was I was trying to make a arbor for a boring head for the mill to make a couple of wrenches to take apart an Albright drill chuck that was broken. So as usual, I'm making tools to fix tools to make more tools to fix other tools, but when I went to thread the arbor, the half nuts would not engage all the way. There's an interlock that prevents the half nuts from being engaged. This rod right here, this rod slides into a gap if these longitudinal or the cross feed if either of them are engaged, this rod won't retract and will prevent the half nuts from being engaged. They were engaging part way, but not closing all the way, and were slipping on the lead screws. So I took it apart. I wasn't exactly sure how the whole thing worked, but thought maybe there was an adjustment that could be made. Turns out that the wear in the longitudinal feed cone, because this oil feed, this tube had gotten plugged, was not feeding oil into the bearing. So this bearing, the cone had worn to where this assembly wasn't moving back far enough when the feed was disengaged to allow this interlock to move all the way into position. Has to go all the way in. Turns out that was a pretty easy fix. I put a spacer on the other end of this assembly to account for the wear in the cone, and that fixed the problem. But when I had it apart, I noticed that because this oil wasn't feeding this bearing, this worm had galled on the bearing, which is just the mild steel worm on this cast bearing surface. So I bored that out and put the bronze bush in to account for that, and also turned down the worm a little bit to get rid of the galled surface. And everything now should be ready to go for another 70 years, hopefully. And I can get back to running my lathe with the way it's supposed to be run, instead of using the threaded rod. And now you can see when the half nut's engaged, the cross feed or the longitudinal feed can't be engaged because this rod has moved in and prevents the assembly from moving to locking on the cone. And then as the half nuts are disengaged and that rod moves down, then the feeds can be engaged. And I still need to do the final adjustments on these, but I've got to do that when they're on the lathe. So now reset the thrust on these two worms, and it'll be ready to go back together. But while I had it apart, I noticed, trying to get it apart, I noticed that this worm that drives the longitudinal feed, the lead screw feeds through this worm. There's another worm here for the cross feed, and is driven by a key that fits in a groove in the lead screw, drives this worm, and then when you engage the longitudinal feed, the cone clutches grab and feed it. But what happened, it appears what happened, is the oil feed from there's an oil pump in the apron, pumps oil into these little reservoirs on top of this casting, and then these feed in to lubricate these as they turn in. They just turn in this cast iron housing. The oil feed to this side was plugged, which also probably accounts for the wear in the cone, because that feeds from there. That feeds from this side also. But as you can see, I actually sanded this down before I decided I was going to make a video. But there was a lot of galling that's occurred on this worm, And this bearing surface in this cast iron housing, I don't know if you can see it or not, is in pretty bad shape. So the next effort is to see if I can mount this casting in the mill and bore that bearing out for a bronze replacement bearing. The other thing that's happened is when this worm's in here, there's a collar that tightens down on the worm and rides on the casting here as a sort of a thrust, and there's a lot of thrust. Most of the force that's on this piece is in thrust. I thought about just leaving this, but as you can see, it's pretty sloppy, so I'm going to redo it. The other reason to redo it is the collar, as you can see, is worn down about 1/8 of an inch into this housing here, which means that you can't take up the backlash. As you can see, the collar was threaded down. It was tightened all the way and bottomed on the thread on the shoulder where the thread ends, which made it a bear to get it off. You can't see that because it's not in frame, but so I'd like to, when I make the bronze sleeve, also include a flange that fits in this groove to accommodate this wear, and also provide a thrust surface for this collar to ride on. And hopefully that'll hold up for another, well, this lasted 70 years, so hopefully it'll last a few more years that way. I suspect it'll probably outlast me at the use it gets. But anyway, like I said, it was just a simple started out as a simple adjustment to the interlock and turned out to be a whole tear down and repair. And so when I get this ready to go into the milling machine, I'll see if I can get some video to show the repair on that. I'm not sure. I've got a boring facing head, but I'm not sure I got enough room to get this casting on the table and get enough room to get it all in there, but we'll see what I can do. Oh, and I was going to show, this is the main apron casting. It's a beast. But put that to set. So the oil pump sits here, down below this. The oil drains in here, and then it's pumped up under pressure through these two copper tubes into a galley. So this fills with this. This galley fills with oil. There's two pipe cleaner I got to replace, wicks that wick down, and these go to the two bearings on the other casting. And oil flows along here and runs down and oils this. This is the gear for the longitudinal. I'm sorry, for the cross feed. And then oil also continues up into the carriage and oils the compound and the carriage is all through these. It continues up through these guys and lubricates the whole carriage and apron are all lubricated by this oil pump. But it is a substantial casting.
I inserted this clip to show the cones that I keep referring to. This is the longitudinal feed assembly. In my hand I'm holding the worm, that is the worm gear that's driven by the worm, and it's got a tapered, it's bored and got a tapered bore that cone fits into. When you engage the longitudinal feed lever, it forces that cone into the taper on the worm gear, and that's what engages the drive and drives it. I'd heard that one of the problems with these is once the cone wears enough, it will bottom in that worm gear. So I was measuring the thickness of the cone compared relative to the depth left in that worm gear to make sure there was enough wear left that it wasn't bottoming bottoming out on the bottom of the worm gear. And now, assuming that I measured everything properly, it looks like I've got about 110 thousandths left of wear available in that cone, which should last for a good long time. I'm going to try and use the horizontal spindle to bore this part out. You can see the galling that occurred on that bearing surface. It's about a little over halfway through. I thought about just cleaning up the worm and running it with what was left, but with the wear on the thrust surface and that, as bad as that was, I thought I might as well fix it while it's apart. Trying to get the part aligned with the spindle on the table, I quickly realized that it's hard to get it to check the vertical alignment until I had it aligned a little better horizontally. I just got a 1 1/4 inch rod kind of loosely clamped into the bore. Didn't have anything that fit the bore exactly, and I didn't have a lathe to make something to fit the bore, so I did this in hopes that it would be close enough to get the alignment where I needed it. I put a dial test indicator on to try and figure out why I was getting erratic readings from the dial indicator. And as you'll see in a minute, it took me a little bit to figure it out, but I did manage to figure out what the problem was. This play when I begin moving the shaft is what was really throwing me for a loop, although I expect experienced machinists would know right away what it was. Turns out the table's loose. So tightened up the gibs for the X direction, which turned out to not be the real problem. The real problem was in the Y. The gib was fairly loose. To be honest, I've never adjusted them since I got the mill. Just never was trying to get anything and set up that precisely, I guess. It never occurred to me. Now that I've got them adjusted, though, will be nice. And as you can see here, that took care of the problem. Well, at least that problem. Took care of one problem. Now I'm trying to align the bore on the casting with the spindle. I've got a dial indicator with the little depth attachment on it, and trying to get it lined up The as I showed earlier, the first third of that bore was actually in pretty good shape, so that's what I'm sweeping to try and get this aligned. Of course, the coaxial indicator I ordered from Shar showed up 2 days after I got this done. But so I'm excited to try and use that at some future point. It was hard enough to try and see this with my own eyes on the mirror's reflection, but to try and video it was... I'm not sure why I bothered, but I did. So I'm gonna show it. It would have simplified things quite a bit had I removed the vertical head, but because I could fit the part in and get the job done without removing it, it was sure easier than pulling the head and then having to retram it when I get it back in. I've got it on pretty good right now, so I figured since everything fit, I'd just leave it and not mess with removing it and then getting it back on and retrammed. But as you can see, I've got well, you probably can't see, but it's within about a 1/2 thousandth on that good part of the bore. The indicator was just held in a TG100 collet. It's just I got it off eBay. It wasn't very expensive, but it's a handy little thing. It's a CDI brand. It says it's made in the USA. It seems to work real nice. Like I said, it was an eBay purchase, relatively inexpensive. As you may recall, the whole event that precipitated this repair was trying to make an arbor for the boring head that I'm now mounting in the mill, and I ended up ordering a Cat 40 boring head holder to do this job, to fix the lathe. Just trying to get the spindle speed set. There's starting up my rotary phase converter. Got a 10 horse idler, and then the horizontal spindle. I decided I'd better put some protection for the mill down, since I was going to be the machining cast iron. Just a couple shop towels with some magnets seems to do the trick to keep all that cast iron dust off the ways. The one thing I really like about having this K&T is the power feeds in X, Y, and Z. As you can hear, the boring tool is in one of the grooves that was galled into that bearing. Now we're hitting a ridge between a couple of the grooves, and then I think we go back into another, or we're back into another one of the grooves. Another nice feature of the K&T is the rapid traverses. So I'm adjusting the boring head for another 20,000 cut. I probably could have taken heavier cuts, but it seemed like 20 thousandths worked really well, and I wasn't taking that much out, so it didn't take that long. Thought I'd show the speeds, feeding at 1 inch per minute, and the spindle's set at 195 RPM. Like I said a minute ago, if you'll be able to see, but taking 20,000 steps of cut. It's the first time I've used this Criterion boring head. I've never had an arbor for it. After I picked it up off of eBay for pretty cheap, actually. I guess maybe it's bigger than most people like, I'm not sure. But after several passes, I'm down to just kind of that one big main groove. As I recall, I think I'd almost take 80 thousandths out before that groove was gone. Here's the last bit of that galling going out. Like I said, I believe this was 80 thousandths total diameter removal to get that. I ended up taking a little more out to try and give enough clearance between the worm and the bore to fit the bronze sleeve in, so the bronze sleeve didn't have to have too terribly thin of a wall. I think we need to request a video from Adam Booth or Keith Fenner or one of those real machinists on how they hold the micrometer and the telescope gauge and get a reading. I need a third hand to be able to do it. I'm not sure how they do it. I've watched, but I haven't mastered it at all. So I ended up shooting for an 85 thousandths wall thickness on the bronze bush based on the diameter of the worm and the amount that I'd poured out of the casting there. I did also have to turn down the worm to get rid of the galled surface on it, so it was kind of a combination of the bore in the casting and the diameter that I cut the worm itself down to. On the final pass, I did a 5 thousandths depth of cut, and then just reversed back out and to take a spring cut to try and make sure the bore was fairly even diameter. I replaced that long boring tool with this stubby one that had a flat end on it to try and face off the worn thrust surface on the end of that bore. I'm trying to adjust the tool to get to the outside edge of that wear surface just by swinging the boring head back and forth as I feed it out. Feed the tool out to just till it starts to drag on that outer edge of where that collar had worn its way into the casting. As you can imagine, with that broad of a cut, there's a fair amount of chatter. Despite the chatter, it made a pretty good cut. Gave a nice seat for the flange on the bronze bushing to sit on. I think that'll wrap up part one, and part two I'll turn down the worm and make the bushing and see if we can get it all to fit, and hopefully it'll all be in alignment too. That was my big concern. Question is, how do you do all that without a lathe? Thanks for watching, and we'll see you on the next one.